which is on magma. It's kind of weird to do this one because I don't have the questions like you do. All right, so the first question, which statement is true about the square root of 50? Well, square root of 50, if you think about it, square root is not a perfect square. There are no two numbers that multiplied will give you 50, and we can express 50, square root of 50, as a ratio of two integers. So let me just write a few here. 64, 36, 25, 16, and so on and so on. But these are perfect square. Why? Because square root of 64 is 8, 7, 6, 5, 4, 3, and so on. But 50 falls in here, in between these two numbers. So it's about 7.1, maybe not even 7.1. But it's, so first of all, it's irrational, right? It's irrational because it can't be, it's not a perfect square. So right off the bat, you know it's irrational. So let me take out B and C out. I know you have the answer here, but B and C are gone. So we know it's either have to be A or D because they're both says it's irrational. But let's say A says it's irrational because the decimal equivalent eventually repeats. No, it's not. It's not repeating. So remember, if it's irrational, right? If a number is irrational, it's a decimal that is non-terminating, which means it goes on forever and ever and ever, non-terminating, and non-repeating. Right? Think about pi, for example. So I'm making this number up, 2.7432132498764932 goes on and on forever. It doesn't repeat. There's no way I can change this into a ratio of two integers, right? Now, if you think about a number like 0.33333333, which can go on, and we can write a 0.3 with a bar notation like that. That we learned early in the year. You might not remember, but I can change that into a fraction. We can rewrite that as a fraction, and eventually we would have gotten 1/3. And because I can change a repeating decimal into a ratio of two integers, that would be a rational number. So these types of decimals, the ones that repeats, are rational, right? It goes forever and ever and repeats are rational. The ones that don't repeat and don't end, go on forever and ever, it's what do you call irrational. Okay, so going back to our multiple choice. D says it's irrational because the decimal equivalent is non-repeating and does not terminate, which we just talked about. Square root of 49, and I know, again, right off the bat, they give you the answer. I give the answer. Square root of 49 is a perfect square. Why? Because it's what number times itself twice gives you 49. It's 7. It's actually plus or minus 7, but let's just use 7 for now. So it's rational because it's 7, and then 7 is a, what kind of number? It's a whole number. It's a natural number. It's a whole number. It's an integer, right? And it's rational, right? I can take 7 and write that as in a ratio of two integers, which, there you go. So square root of 49 is rational. All right, so let me see if I can do this without showing. Square root of 32, again, repetition. Right, so again, so if you go through your perfect squares, right, and you might want to memorize the first 10, think about it. Square root of 25, we know, square root of 36, so think about this. 6 to the second power, 5 to the second power, 4 to the second power, 3 to the second power, so that'd be 16. 9, right? So square root of 32 is in between the two perfect squares, 6 and 5, 36 and square root of 36 and 36, square root of 25. So square root of 32 is going to be irrational, right? Because it's decimal when we change, if you put that in your calculator, square root of 32 is going to be a non-terminating. And then again, non-repeating. So it goes on forever, never, doesn't repeat, never ends, which makes it irrational. Yeah, very repetitive. It's classified 1.234 as rational or irrational. Well, it's rational. Why? Because first of all, it ends here. So we don't have to worry about it repeating, terminating, or non-terminating. It's just 1.234. Can I rewrite that as a fraction? Can you write that as a fraction? Yeah, we can. If you look at the place value here of the 4 is in the thousandths place, right? And then to change this as a fraction, write this as a ratio of two integers, we would just write 1, 2, 3, 4 there. 1.21 and 234 thousandths can be written as 1,234 over 1,000. And if you think about it, right? No, there's nothing to think about. That makes it rational. Okay. 5, 7 over 2. Well, first of all, 7 over 2 is already written as a ratio of two integers. It is a ratio of two integers, right? 7 is an integer, and so is 2. So it's written as 7 a ratio of two integers, 3.2, or if you want to talk about 3.5. And if you change 7 over 2 to 3.5, and what's 3.5 is a terminating decimal, right? It's a decimal that ends, right? And if so, these two, you can use these two as reasons to say that, hey, which makes them rational. All right, and 3.5, again, can I take 3.5 and write it as a ratio of two integers? Yeah. Where's the place value of the 5? It's in the tenths, so we can write like that. And if you think about it, 10 goes into 3. If you can simplify this, divide top by 5, which gives you 7. Divide the bottom by 5, which gives you 2. Look, it's the same. So we know it's rational. Questions are here. 6, 1.3, rational or irrational. So again, this is a 1.3 is a repeating decimal, and any repeating decimal is a rational number because we can write it as a ratio of two integers. And let's go over that in case you forgot. So 1.3, right, is actually, let me actually write this like this for now. So the 3 is repeating, right? So what I'd like you to do is set an equation and say x equals 1.3333333. There's one number repeating, which means if you remember, right, I want to move that decimal 1 over. So I'm going to multiply top and bottom line by 10. So I'll multiply this x by 10, I get 10x. If I multiply 1.333333 by 10, all it's saying is that it increases by a factor of 10. So the answer would actually be just this number with the decimal 1 over to the right? That's the shortcut. So that I would get 13.333333 forever and ever. So I multiply x by 10, I get 10x. I multiply 1.333 forever and ever by 10, I get 13.3333. Now, remember what we did next? We subtracted both equations. 10x minus x is 9x. And then when you subtract this, notice what happens to our repeating part. All these repeating 3's, look, 3 minus 3 is 0. They all eliminate each other. So the repeating part disappears. I end up left with 13 minus 1, which is 10. Sorry, which is 12. Okay. And then we divide both sides by 9. X equals 12 over 9. And 12 over 9, let me write that down first. Let's divide top and bottom by 3. I get 4 over 3. And what's 4 over 3? It's 1 and 1/3. And isn't 1/3 the same thing as 3.3333 repeating? Yes, it is. So can I write 1.3 repeating as a fraction? Yes, I did. Here it is, 4 over 3rd. And if I can write it as a ratio of two integers, then it makes it a rational number. Seven equations. Oh, okay. So let's solve this. 3x plus 1 equals x plus 1 plus 5x. Well, there's 3 properties, so let's take care of that first. 2 times 3x is 6x. 2 times 2 is 2. Combine like terms, the x and the 5x, I get 6x plus 1. So I did a distributed property. I combined like terms. Look, there's variables on both sides, right? So let's do minus 6x, and you'll notice that the variables are going to go away, and I'm left with an equation that says 2 equals 1, and we know that's not true, right? There's no way 2 equals 1. So what does that tell us? It tells us that there is no value of x that I can plug in here and here and here to make one expression, the expression on the left, equal the expression on the right. So what does that mean to us? It means that it has no solutions. Okay. 9. Ugh. Okay, so hopefully you'll remember some of this. So which expression has a value of 1 over 16? Right, so it could be a calculator problem, but your calculator might not give you 1 over 16, might give you a decimal. So let's start with the first one. 2 to the negative 4th to the negative 1. It's an exponent raised to another exponent. So what's the rule? Exponent to another exponent, the rule was multiply the two exponents. So we get negative 4 times 1 is just positive 4. And positive 4, right now the negatives are gone. 2 to the 4th is 2, 4, it's 2 times 2 times 2 times 2, which equals 2, 4, 8, 16. Is that what we want? No. So A is not it. B, 2 to the 4th times negative 1. Well, let's do exponent to exponent, so we get 2 to the negative 4th. Well, notice there's a slight difference between this one and the previous one. Remember what we did when there's a negative exponent? We want to make it into a positive, so we're literally going to write this to a negative 4th over 1, but then that allows us to change this to a positive. Right? Now I can actually go ahead and find what 2 to the 4th. So on the top is just 1, and 2 to the 4th is 16. Look at this. And that's exactly what we want. B is our answer. Okay. 9. This is a extended answer. So some guy is saying that 5 to the 7 over 5 to the 3rd is the same as 5 to the 6 plus 5 to the negative 7. Well, good chance for you to review your rules. 5 to the 7, 5 to the 3rd. What does that mean? Well, let's expand this. That means 5 times 5 times 5 times 5 times 5, 1, 2, 3, 4. That's what the 5 to the 7 power is. 5 multiplied by itself 7 times. And 5 to the 3rd is 5 times 5 times 5. Let's simplify. This 5 and this 5 can be simplified to 1. This one can be simplified to 1. This one can be simplified to 1. So I'm literally left with, let's say on the top, 5 to the 4th power over 1. Well, let's just write this for you. So that's how you divide exponents, right? Divide bases with the same exponent, right? If you want to expand, you can expand. If you don't remember, so if you want to take the shortcut, you didn't have to do all the work that I did. Just think about it. Hey, on the top I have 7 5s being multiplied, and at the bottom I have 3 5s being multiplied. If I simplify, where am I going to have leftovers? I'm going to have leftovers on the top in the numerator. This one, it's the product rule. When two numbers, right, and when the bases are the same, in this case they're both 5s, and they both have exponents, what do we do with the exponents? We actually add the exponents. So 6 plus negative 2 is actually 5 to the 4th. Is that the same thing as this guy? Yes, it is. So and we talked about all the properties, and the answer was yes. 10, 15 to the 3rd times 15 to the negative 7. The problem with you putting this in your calculator, and I'm going to do that right now, is that it doesn't give you your answer in 15 to whatever power. It actually gives you a decimal, whatever answer that is. So let me just do it. 15 to the 3rd power times 15 raised to the negative 7th power. So if I put that in your calculator, this is the answer that I get on the calculator. 419,753, right? And that's not the answer that you and I worked on earlier in the year. We'd actually left it in exponential form. So again, remembering the rules, this is multiplication. So when we multiply and the bases are the same, we keep the base, and we add the exponent, 3 plus negative 7. 3 plus negative 7 is 15 to the negative 4th. We're not done yet because it's a negative exponent, so we got to change that, rewrite it. Let's put this over 1, and now 15 we can change it to positive 4. If you wanted to put 15 and raise to the 4th power and see what you get, go ahead. But that's how we left it earlier in the year. Now, which of these 4 looks like this one? And that's the one we're looking for. 11. Again, another just practice. 4 to the negative 5th times 4 to the 8th. The bases are the same. We keep the base. We're going to add the exponents. And negative 5 plus 8 is just 3. 4 to the 3rd. Or sometimes maybe they leave you the answer as this. But this is an exponential form. Actually, none of these have 4 to the 3rd power. So they all left it in something different. So let's go one by one. Let's look at A. A says 4 to the negative 2nd and 4 to the negative 1st. So, I don't like that they did that, but hey. First of all, notice that they're both negative exponents. Let's change them to positive. So 4 to the negative 2nd, right? Actually coming down here, and that becomes positive. 4 to the negative 1st, well, it can't go down. It's going to go up. Actually, it can, but it becomes that. And if you continue here and expand on the numerator, I just have 4, and the denominator I have 4 times 4. This and this can be simplified, and I actually get 1/4. 1/4 is nowhere near 64, so A is gone. B. You do B here. 4 to the 3rd power raised to the negative 1st power. Well, power to a power, you get to multiply. You get 4 to the negative 3rd power. Notice that the exponent is negative, so again, change the fraction over 1. So make it that 4 to the 3rd power. At the bottom, the denominator. 4 times 4 is 16, and 16 times 4 is 64. So again, 1 over 64, close, but again, B is not it. C. 4 to the 2nd, and 4 to the negative 1st. Well, I don't like that this exponent is negative, so 4 to the 2nd I'm going to keep, but 4 to the negative 1st, I'm going to move into the numerator. I move into the numerator, the negative 1 becomes 1. Then I get 4 to the 2nd times 4 to the 1st, which is 4 to the 3rd. And then 4 to the 3rd is equal to 64. So C is what I want. 12, okay, a little bit more. 12 is 5 to the negative 2nd raised to the 5th times 5 to the 4th. All right, so a little order of operations we have to do. So let's take care of this first. It's a power to a power, so negative 2 times 5 is negative 10, and then times 5 to the 4th. Now it's a product rule. Keep the base, add the exponents. Negative 10 plus 4 is negative 6. We don't remember, we don't leave our answers with negative exponents, so that's going to change to 1 over 5 to the 6th power. And that gives us C as our answer. 13. More of these. Okay. 5 to the negative 2 raised to the 5th times 5 to the 4th. Negative 2 times 5 is negative 10. I think it's the same question. I think I just did that. Did I just do that? 12 and 13 the same? Yeah, it's exactly the same. What a waste. 14. 7 to the negative 8 times 7 to the 3rd. Keep the base, they're the same. Add the exponents. Negative 8 and 3 is negative 5. Don't leave your answer as a negative exponent. We write that, so the 7 has a positive exponent. So we write that as 1 over 7 to the 5th power. Well, actually, they left it with a negative exponent, so there's our answer. We didn't have to change it to positive. I guess your multiple choice answers dictate what we do. Which expression is equivalent? Oh, boy, this one didn't have the actual question. 16. And we have 2 to the n, 2 to the 2nd power, times 2, and we're going to put a little box over here, equals 2 to the 4th raised to the 3rd. All right, so remember, an equation is the expression of the left equaling the expression of the right. So let's simplify the expression of the right. 2 to the 4th raised to the 3rd power is just 2. Remember, power to power, multiply 2 to the 12. Now let me copy the left side. So we're missing something. 2 to the 2nd times 2 to what power would give you 2 to the 12? Remember, product rule, What am I doing with these two? I'm adding, right? So 2 plus something equals 12. So the answer would be 2 to, and in this box, we're going to write 10. And that equals to 2 to the 12. Makes sense because the bases are the same, so you would keep the 2 and you would add 2 plus 10, and that gives you 12. I'm going to find a better way of doing this video. Anyways, 2 to the second times 2, and then 2 to the 4th. Well, there are a lot of things, there are a lot of different ways to do this. Okay. So we're multiplying. So on the top, we can multiply 2 to the second times 2, and remember there's an invisible 1. So really on the top is keep the base, 2, add the exponents, 2 to the third, and at the bottom is 2 to the 4th. Can we simplify? Well, yeah, we can. I don't like that they wrote the answer like this. It's correct, right? But I still don't like it. On the top, it's 2 times 2 times 2. That's what 2 to the third means. 2 to the 4th is 2 times 2 times 2 times 2. Simplify becomes 1. Simplify becomes 1. Simplify becomes 1. Right? So all that becomes 1. If you now go 1 times 1 times 1, on top you have 1. And at the bottom, you have 1 times 1 times 1 times 2, and just becomes 2. And 1 over 2 is the same thing as 2 to the negative first power. Think about what this means. We're going to change that to a positive exponent, so turn it into a fraction and make it 2 to the first. Are they exactly the same? Yes. I'd much rather they had written the answer like this. I don't know why they wrote it as a negative exponent. They should have done. Simplify. Okay, again, it should be pros by now. 5 to the negative 8th times 5 to the 4th. Keep the base, add the exponents. Negative 8 plus 4 is negative 4. It's a negative exponent, so we're going to change that to a positive exponent. So put it over 1 and make it 5 to the 4th. And this one, look, they did it correctly. 19. Ugh, what is this? Did Jude simplify correctly? Well, let's try. So 1 over 2 to the second power times 1 over 2 times 1 over 2 to the third power. This, ladies and gentlemen, is no different than this. A to the second times A times A to the third. Let's think about this scenario first. Remember, on top of the A here, I'm going to put an invisible 1, right? The invisible 1 that's there. Let me just make it visible. Are the bases the same? Yes, they are. A. What do I do with the exponents? I add them. 2 plus 1 plus 3, and I get 6. So the answer here would be 2 to the 6. Okay? Well, let's repeat this with this that I have here. It's half times half to the second times half to the third. Well, the bases are the same, so I'm going to keep the half. What do I do with the exponents here? I'm going to add them. 2 plus 1 plus 3 is 6. So it's a half raised to the 6th power. What does that mean? It's a half times a half times a half times a half times a half. 1, 2, 3, 4, 5 times a half. 6 times. Did this person did it correctly? No, they did not. So see what they did? You're supposed to keep the base, a half, and they actually didn't. They actually multiplied half times half times half, and they got 1 over 8. They added the exponents, 2 plus this invisible 1 plus 3 is 6. So the 6 exponent, they got it right, but I don't know why they multiply half times half. So you keep the base, right? Don't do anything with the base. Right? Just like 5 to the third times 5 to the fourth times 5 to the second. What do we do here? We keep the base, which is 5, and we add the exponents. 3 plus 4 plus 2 plus 9. Right? Whether it's this or a fraction, the base here is the half. So half was kept, and we added the exponent. So it's 1 over 2 to the 6th power, and 1 over 2 to the 6th power is, if you look at the numerator, is 1 times 1 times 1 times 1, which is just 1, and then 2, 4, 8, 16, 32, 64. So your final answer should have been that. I think we saw that on one of our tests. 20. 20 is the same. I don't know what. Simplify. It's the same exact question we just did. 21. 2 to the negative 5th times 2 to the 8th. Keep the base. Add the exponents. Negative 5 plus 8 is 2 to the third. You can simplify this as 2 times 2 times 2, which is just 8. So look at your multiple choice. It's either this one or this one. Well, in this case, they left it. I can't see the multiple choice for some reason. So this is what they're saying the answer is. Well, we know the answer is 2 to the third, right? So they're saying that the answer is 2 to the second and 2 to the negative first. Why? Well, because the negative first is a negative exponent. Yeah, it has raised to a negative 1. So we keep the numerator stays 2 to the second. But this guy here, because it's a negative exponent, we're going to make him go to the numerator, turning that negative 1 to a positive 1. The bases are the same, so we keep the base, add the exponents, and we get 2 to the third. So this is the correct answer because it's the same thing as 2 to the third. Not liking these questions. This one, oh my god, 3 to the fourth divided by 3 to the second. You can literally put this in your calculator, this one, but I'm going to do it a long way. Expand 3 to the second. 3 to the fourth is 3 times 3 times 3 times 3. 3 to the second is 3 times 3. Simplify, simplify, becomes 1, becomes 1. This one, simplify, simplify, becomes 1, becomes 1. So on the top, I have 1 times 1 times 3 times 3, which is just 9. At the bottom, 1 times 1 is just 1. We don't need to write 9 over 1. We're just going to write 9. Okay, again, apologies. These questions are, it won't happen again. 4 to the 7 times 4 to the negative fifth. Keep the base. Add the exponent. 7 plus negative 5 is 4 to the second. So I don't know if they left it as 4 to the second or 8. Or 16. Oops, 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 oops. 16. So either this was the answer or this was the answer, depending on what they felt like. 24. Simplify. So again, 4 to the 8th divided by 4 to the negative 4th. Think about what that means. Well, let's work that negative exponent to a positive exponent. So actually, 4 to the 8th, and then this, because it's negative, we're going to move it to the numerator. The base stays the same, but the negative exponent becomes now positive. And this becomes 4 to the 12th. 25. Okay. 6 to the third, 6 to the sixth. The answer is incorrect, by the way. 6 to the third is 6 times 6 times 6. 6 to 6 is 1, 2, 3, 4, 5, 6. Can we simplify? Yes, we can. Right? 6 over 6 is just 1. 6 over 6 is just 1 again. 6 over 6 is just 1 again. So all that in the numerator is 1 times 1 times 1, which gives me 1. At the bottom, notice that I have 3 6's left. So let's write that in exponential form and write 1 over 6 to the third power. X cubed. Remember what you have to do here. Right, so if you have your calculator, no, actually you don't need a calculator. If you did have the calculator, right, how do we get this to look like this? We're going to take the cubic root of that side and the cubic root of the right side. We're looking for a number that multiplied by itself 3 times gives me 125. And that would be 5, because 5 times 5 times 5 is 125. So the answer to this is 5. 27, same exact question. X to the third equals 64. Take the cube root of this side, take the cube root. Don't forget to write that little 3 there, because if you don't, it's the square root. So that and that simplifies, which isolates my x, is what we want to do. And then cube root of 64 is 4, because 4 times 4 times 4 is 16. 28, area question. Please, for the love of God, don't get these wrong. It's a square. And they're saying that the area of this square is 324 square feet. Square. What does that mean? Well, it's a square. So in a square, all the sides are the same, right? So let me draw a square here. If I asked you for the area, and this was A, and this was A, it would be A times A, or A squared. And that's how you find the area. Example, if this was 3, we know that this is 3 because it's a square. So what's the area of this? 3 times 3, or 3 to the 7th power. Both gives us 9. So they're actually giving us the answer. Something multiplied by itself gave me 324. So how do we set up the equation? Well, we can say, hey, x squared, right? Because We multiply the same number twice. Let's say this is x, so this is x. So x times x. So the equation is x times x equals 324. Right? We multiplied the same sides, and that gave us 324. Let's write x times x as x squared. Right? Same thing. Now, what does that allow me to do? Well, I'm going to take the square root of both sides. And I finally get x and take the square root of 324. I have no idea what it is. And it's 18. Sorry. So the area or the side lengths of this square, right? So we had a square where the area was 324, which meant this side was 18 and this side was 18. All right. Okay. That is, I think, the last question. Yes.